Welcome back, ladies and gentlemen. So we came across that electron transport chain in the steps of the light reaction. So let's just take a moment to look at the comparisons of what that electron transport chain and chemoosmosis function and look like in your mitochondria, which we came across as part of your cellular respiration process, as well as what it's doing here in our chloroplasts in photosynthesis. So they're both going to generate ATP. They're both going to produce hydrogen gradients, and they're both going to utilize chemoosmosis and that ATP synthase enzyme to be able to produce all of that ATP. So the big difference becomes, where do the electrons come from and where exactly are we building up that gradient? So from your mitochondria, we're transferring that chemical energy we store in food and creating those NADH molecules, those FADH2s from glycolysis, and from your citric acid cycle and pulling the electrons off of those electron carriers to be able to drive that electron transport chain and build up that hydrogen gradient. In chloroplasts, it's going to come from the light energy that we're harnessing and stealing electrons from those chlorophyll molecules in those reaction centers to be able to build that ATP. So there are definitely spatial differences and yet similarities all at the same time. So when we look at your mitochondria, we've got that outer membrane, inner membrane that's got all of those folds, those cisternae or cristae, depending on who you talk to and how to pronounce it. And then you have that jelly-like substance matrix in the middle. So we've got that electron transport chain bound in the inner membrane, and we're pumping those H pluses from the matrix into that inner membrane space and then allowing them to fall back through ATP synthase back into the matrix. When I look at your chloroplasts, right, we are bound in that thylakoid membrane. We're building up that H plus concentration inside the thylakoid space and then allowing them to fall back out into their stroma, which is their jelly-like substance. So we're taking those H pluses, driving them into a gradient within a membrane so that they can't fall back through except where we want them to, and then allowing them to diffuse through the ATP synthase enzyme. Remember, every time that does that, it rotates and smashes together that ADP and that phosphate to make ATP. And then where do the H pluses go? Well, in the case of your mitochondria, those H pluses plus the electrons themselves get coupled with the oxygen to make water. In your chloroplast, those electrons go to the next photosystem, and those H pluses are ultimately going to be used in that next electron transport chain coming off of photosystem 1 to then make NADPH. So if we look in summary, here's what that whole process now looks like. All right, so you've got your photosystem 2, photosystem 1, here's the electron transport chain, and as well as the second smaller electron transport chain to make the NADPH. All right, so light comes in, pass that energy around by exciting electrons and allowing them to fall back to ground state. We excite that final electron, chlorophyll in the reaction center. That electron gets shuttled down that electron transport chain. We replace those electrons by splitting water. Oxygen comes off as a byproduct, as well as H pluses that we ultimately need. Some of the H pluses that are hanging out here in the stroma get pumped through as well so that we build up a huge H plus concentration here in that thylakoid space. We allow those H pluses then to diffuse through that ATP synthase to make us the ATP that's ultimately going to go to the Calvin cycle. The electrons that are flowing down that electron transport chain replace the excited electrons on P700 in photosystem 1. The electrons that get excited there get shuttled down this small electron transport chain and use the help of the NADP plus reductase enzyme to now make NADPH along with some of the hydrogens that are hanging out here in the stroma. And those will also get shuttled over to that Calvin cycle.